Water flows at the rate of 0.147 meter cube per second through a 150 mm diameter orifice inserted in a 300 mm diameter pipe. The pressure gauges fitted upstream and downstream of the orifice plate have shown the readings of 176.58 kN per meter square and 88.29 kN per meter square respectively. Find the coefficient of discharge C of the orifice meter. Okay, so the given problem is orifice meter problem. Okay, so first of all, here capital C means what? In this question, capital C means coefficient of discharge of the orifice meter. So we have to find capital C. So first of all, let us understand this question, and we have to write given data. Given data. So here given discharge through the orifice. So rate of 0.147 meter cube per second. So meter cube per second is a unit of discharge. So given discharge through orifice meter. Okay, discharge denoted by Q. So discharge through orifice meter is how much? 0.147 meter cube per second. Okay, so next, given diameter of the pipe. Diameter of the pipe. Diameter of the pipe. Let us say D1. So D1 how much? 300 mm. Convert mm into meters. 300 mm means 300 by 1000 meters. Okay. So why? Because we know 1 mm is equal to 1 mm. Remember, 1 mm is equal to 1 by 1000 meters. Okay, now unit conversion is very important. 1 mm equal to 1 by 1000 meters. So 300 mm is equal to 300 by 1000 meters. So 300 by 1000 how much? 0.3 meters. So D1 is equal to 0.3 meters. So diameter of the pipe is 0.3 meters. Next, diameter of orifice is given. Diameter of orifice. So diameter of orifice means D2. D2 150 mm. Okay, so 150 mm can be written as 150 by 1000 meters. 150 by 1000 means 0.15 meters. Okay, D1 no D2. Okay, next and here a pressure gauge is fitted at upstream and downstream of the orifice plate, and we got the readings. P1 is equal to upstream pressure. P1 means upstream pressure. So P1 how much? 176.58 kilonewton per meter square. Okay, so it can be written as P1 equal to kilonewton means 10 cube newtons. 1 kilonewton is equals to 10. Kilo means 10 cube. So 10 cube newton per meter square. Okay. And what about downstream pressure? Downstream pressure P2 is equal to reading of downstream pressure 88.29 kilonewton per meter square. So let us convert it into newton per meter square. So kilo means how much? Again 10 cube. So into 10 cube newton per meter square. Okay. Now we have P1 and P2. Still, is there any other information? That's all. Okay. So based on this given data, we have to find coefficient of discharge of orifice. Okay. So what is the formula for discharge through a orifice? We know that discharge through a orifice is given by Q is equal to C into A1 into A2 root over 2GH whole divided by root over A1 square minus A2 square. Okay, na? This formula is useful to find discharge through a orifice meter. Okay, na? In order to find discharge through a orifice meter, we use this formula. Okay, na? Not only orifice meter, this formula is also useful for discharge through venturi meter. Okay, to measure discharge through a orifice or venturi meter, we use this formula. Q is equal to C into A1 into A2 root over 2GH by root over A1 square minus A2 square. In general, we consider CD. CD means coefficient of discharge, but in this question, he given capital C. Coefficient of discharge through orifice meter is capital C. That's why we considered capital C. Okay, next. So here we have to find capital C. And what about A1 and A2 here? In this formula, A1 means area of cross-sectional area of pipe. Okay, so A2 means cross-sectional area of orifice. So area of pipe. So area of pipe formula pi by 4 into d1 square. Area of orifice pi by 4 into d2 square. Okay, so let us find A1 and A2. A1 is equal to pi by 4 into d1. How much? Diameter of pipe is 0.3 meters, so whole square. So pi by 4 into 0.3 whole square, how much? You will get approximately 0.0707 meter square. Okay, and what about A2? A2 is equal to pi by 4 into d2. D2 how much? 0.15. D2 means diameter of orifice, 0.15 meters. So if you calculate, you will get 0.0177 meter square. Okay, now approximate values. Now we have A1, A2. So what about H? H means differential head, manometric head. Differential manometric head, or we can say head, pressure head. Okay, so now we have to find the pressure head H. Okay, or manometric head H. So here H means head of water. Okay, now in meters. So what is the formula for head of water? H is equals to delta P by rho G. Delta P by rho G. Delta P means change in pressure. So upstream pressure minus downstream pressure by rho G. So P1, upstream pressure, how much? So here in this question, upstream pressure is how much you given? 176.58 into 10 cube minus downstream pressure how much? So you given downstream pressure 88.29 into 10 cube by rho. Rho means density of water. Density of water 1000 kg per meter cube. G means acceleration due to gravity 9.81. Okay, so let us simplify further. So 176.58 into 10 cube minus 88.29 into 10 cube. Here 10 cube, here 10 cube common. Take out 10 cube. 176.58 minus 88.29 whole divided by 1000 means 10 cube into 9.81. 10 cube get cancelled. 176.58 minus 88.29. So if you subtract, you will get 88.29 divided by 9.81. So 9.81 ones, 9.81 nines. So 9 meter of water. So head H is equal to how much? 9 meter of water. So we have got H is equals to 9 meter of water, which is equals to 9 meter. Now we have A1, A2 and H. Okay, so Q is already given. So Q how much? 0.147 meter cube per second. Let us substitute all values in discharge formula. So what is the discharge formula? Discharge formula Q is equal to C into A1, A2 root over 2GH by again root over A1 square minus A2 square. Okay, so let us substitute all values. Q how much? 0.147. Okay, na, is equal to C into A1. So A1 value how much? 0.0707 into A2 0.0177 into root over 2GH 2 into 9.81 into H 9 whole divided by root over A1 square minus A2 square. A1 square means 0.0707 whole square A2 square means 0.0177 whole square. Okay, so we have so many calculations here. So let us simplify one after another. 0.147 is equal to C into 0.07 into 0.01774, 07 into 0.0177 into root over. So 2 into 9.81 into 9. So its value is approximately 176.58. Okay, na? Whole divided by root over. So if you calculate 0.0707 whole square minus 0.0177 whole square, you will get 0.0046852. Okay, so 0.147 is equal to C into, if you calculate 0.0707 into 0.0177 into root over 176.58, okay, so you will get 0.01663 whole divided by root over this. Root over of this value is 0.06845. Okay, now so C into, so if you calculate 0.0166 by 3 and 0.06845, so its value is approximate value 0.243. Okay, now 0.147 is equal to C into 0.243. Here we need value of C, then C is equal to what? 0.147 divided by 0.243. So multiplication becomes division. Now what is the value of C? We need value of C. So 0.147 by 0.243, you will get 0.605. So what is the value of coefficient of discharge? 0.605. So therefore coefficient of discharge of a orifice meter C is equal to 0.605. This is the final answer.